All right, welcome to the second half of Monitorama. So I just wanted to actually, before we get started, call out Jason and Will and the whole Monitorama crew for dealing with the interesting situation this morning. They've been doing a great job making sure that the speakers are up to date, you're all up to date, so I think we should give them a round of applause for that. They've done a great job. The one thing I will say, I don't know why they just didn't load the holodeck program from yesterday's. That's kind of odd. Also, channeling my inner Joe D'Amato, greetings Pacific Power. They tweeted this morning, and I know of at least one person who might have a question or concern about their service. So you might be saying to yourself, chaos. That's kind of interesting, whispers in chaos, what is that about? Well, today we're going to be talking about incidents. And I'm going to do a little survey to start us off. And I want you to keep your hands raised. Raise your hand if you're an operations person who deals with incidents. All right. So raise your hand if you're a developer who gets pulled, keep them up, or raise your hand if you're a developer who gets pulled into incidents. And raise your hand if you look at these people working incidents and just want to know when the website's going to be back up. Okay, that's like pretty much everyone in the room, right? So there's an interesting question that comes up. How do you know an incident is occurring? How do you know an incident is occurring? We're at Monitorama. Monitoring. It's not a trick question. Someone in the corner is like, Lisp. Lisp is how you know that incidents are occurring. No, just monitoring. But so once you know that an incident is occurring, then it's a good question to ask, well, how do you know what to do when an incident is occurring? And you might think about that. Like, have you ever thought kind of in a meta sort of way, how do you know what to do when an incident is actually in progress and you're responding to it? How do you know what your team is doing, right? So a little bit about me. I'm not going to go through this slide. This slide is mostly about the tweets, so you can tweet me. It's got my Twitter name. The other thing that I would note is I'm currently a Masters of Science candidate in Human Factors and System Safety. And the reason I mention that is because a lot of the things that we're going to be talking about actually come from the Human Factors and Systems Safety Sciences. So the first part to sort of answering this question of how do you know what to do when an incident is occurring is to look at how humans react to problems in general, how the human brain reacts to problems. And you might have heard of this. There's generally two systems in the brain. This idea of system one, which is sort of automatic, quick, no effort, no real sense of voluntary control, if you will. And of course, then this idea of system two, that actually takes time and attention. Our brain actually has to use some sugar to do some work, right? And what's interesting about system two, actually, is that when your attention gets diverted and you're doing a system two problem, work on the system two problem actually stops. It's kind of interesting. Now, if you've heard this theory, it's from Thinking Fast and Slow. This book is a really interesting book. It's a very thick book. I think it's like 600 pages because it covers all of Daniel Kahneman's work throughout his entire career. He won a Nobel Prize in economics, I believe. So what do we mean by, what are some examples of systems one, systems two type thinking? Well, system one, complete the phrase bread and cheese. That works. Bread and butter, right? 2 plus 2, right? Stuff like that. One of the things that we'll come back to that I find really interesting, finding a strong chess move is actually a system one thinking if you're a chess master. So that's kind of interesting. And then, of course, system two, the examples they give there, counting the occurrence of the letter A on the slide. I like that filling out a tax form is supposedly less complicated than checking the validity of a complex logical argument. So, like most things with the brain, though, it's more complicated than that. And that doesn't necessarily tell us much about how we might react ourselves and how our team members might react while we're dealing with an incident. So to look at that, we're going to look at some research that this gentleman did. And if you know who this is John Allspaw. He worked on the Velocity Conference as one of the conference co-chairs for a number of years. And he actually did his thesis on exactly this issue. If you can't read that, it's Trade-offs Under Pressure, Heuristics and Observations of Teams Resolving Internet Service Outages. Are there any people, I know there's at least one person from Etsy. Are there any other people from Etsy? because if you probably knew this, he studied one of Etsy's incidents. So the beginning of the incident on December 4th, 2014, during the busy holiday shopping season, it was reported at 1:06 p.m. that the personalized homepage for the logged in users was experiencing loading issues. So that was the incident, and that's what the engineers working that incident were faced with in terms of that was the information that they had. Now, if you've seen me present before or you've read Sidney Decker's Field Guide to Understanding Human Error, you've probably seen this before. This is his sort of example of what a really good timeline would look like. And so you can see it's got data, it's got what people actually did, and of course what people said. So one of the first things John Allspaw did is he actually made an incredibly detailed timeline for this incident. So this is kind of a data trace just for one engineer that shows a number of things, the diagnostic activities that they took, the actions and responses. He actually had logs of dashboard access, so he could look at what logs people loaded in their web browser. Also staff directory access, so who were people trying to find information to go talk to. Princess requests, which I believe have to do with deployment, is that right? Pre-production, yeah. And then production site requests. And so what's interesting is because software is a team sport. Oh, one last thing real quick. And he also basically identified what he calls episodes. So that's what these lines are. So he was able to start correlating, okay, well, if you look across all of these things that this one engineer is doing, and there's a timeline up here, a time-stamped line that shows these episodes, well, because software is a team sport, he actually did this for all of the engineers involved. And this is a bit of a different trace. This is actually a trace of IRC lines in an IRC log. So when who said what. So he identified 3 heuristics, or what we might call sort of monitors for our brain, things that our brain might look at, that engineers use to work on an incident. Oops. Heuristic number 1, change. Did anyone change anything? Did anyone deploy anything? Was there a commit that got through the continuous delivery pipeline? Answering this question, so what has changed since we last had a good known state? So that's the first thing that engineers go to, right? Who changed what? When did they change it? And that seems pretty natural, right? That's probably what a lot of us do. But then the question is, okay, well, what happens if nobody changed anything? And that's actually the case in this particular incident. There were no deploys at the time. There were no commits that had been committed. So what do you do then? Well, in talking with the engineers, he found the second heuristic that those engineers used as operations engineers was to actually go wide, right? And it's funny to read the transcripts from the interviews that he did afterward, because there's a sense from all of them that when I don't know what it is, there's actually, the funny thing is there's a bit of a sense of dread, and also okay, time to go as wide as possible. So we go sort of from thinking about the problem on Earth to like, what could it be at all in all of the universe? And start looking at all sorts of things. Now, this was described by an engineer actually as sort of oscillating between a breadth-first search, and then when you see something, one thing that it might be that, then immediately switching to depth first and going as deep as you can on that particular issue. And as soon as you find that it's not that, or you rule that out, you actually go back to breadth first. And he had a number of engineers say that that's when they think of that problem, they go breadth to deep, back to breadth when it's not successful. So, one of the other interesting, the third heuristic that he found actually kind of facilitates this going wide, if you will. And he called it convergent searching. So, confirming and disqualifying diagnoses by matching signals and symptoms. So this is that idea of how do you actually make that switch between breadth first to depth first back again? What is the heuristic you actually use to do that? And so what he actually found is that engineers are confirming or disqualifying a specific and past diagnosis that comes to mind. So in other words, they will think of things in the past that was very unique and specific that sticks out to them to this day, and they will use that to confirm or disqualify the signals and symptoms that they see or hear. And the other thing that he found is that people will also use their general and recent diagnoses to actually look at these situations. And if you think about it, this is actually kind of fascinating. What this actually is saying is people either use a really, really painful incident that they remember for like their entire career, or they use the stuff that's in your L1 cache from the last incident that you had. And what's interesting about this is that the generalized things are the only things that stick in your L1 cache. So you will remember very specific things that 36-hour incident that you worked, you will tend to remember details in that system and look for those. But when it comes to past incidents that you may have run that may be smaller in scope, you're really only looking for generalized patterns that you can see. So that's kind of interesting that we split that third heuristic really supports the second one. So, back to the incident. Well, you might be asking yourself, okay, well, what actually happened? What was it? And it turns out it was kind of an interesting confluence of events. It was caused by a CDN cache miss due to an HTTP 400 status in an API from a closed store. So they have stores that get closed for various reasons, non-payment, things like that. Referenced by a blog post in the sidebar from an employee. So what had happened, and you want to talk about the confluence of complex systems, an employee had written a blog post, and a lot of the engineers actually thought it was to do this featured shop module or some of these other modules on the sidebars, but it was actually more from the blog module. That employee posting that post caused the page renderer to make an API call for a closed shop, and nobody ever thought that that connection would actually work. And then because of the cache misses, it was causing this page to take 4 seconds to load, and when you're doing this during Cyber Monday, it's a problem. Right? So this is what's called a process trace, and this is kind of the other way to look at it. And I want to point out a couple really interesting things that sort of go back to that idea about heuristics. So the first thing is that infrastructure engineer 2, and you can see that person is, most of their work is represented here and a little bit down here. They focused on frozen shop, which was basically the problem, relatively early on in this process. And if you go back and look at the transcripts, you've got all of the other engineers, network changes, WordPress issue. Somebody asked featured shop, right? Featured shop loading, okay. But this engineer in particular sort of fixated on the frozen shop issue and kept working it for, if you look at the time they took to work it, a relatively large portion of this incident. So that was kind of interesting, and it turns out that that engineer was correct, and the reason that they thought it might be that issue is because one of the first incidents they had ever worked turned out to be a closed shop issue. So that was an example of that first heuristic where it was something that was very painful to them, and they always remembered that you always look to see if the shop is frozen first. Now, one of the other interesting examples that showed up in the research is when John went to interview the engineers, and he sat, I think it was infrastructure engineer number 1, sat the engineer down and asked them about this incident. They immediately recalled something about a varnish cache issue, which was not the cause of this incident at all. But it shows that principle of general things that we remember, but only for a short time, that L1 cache, if you will, of incidents. But it's not very specific. It's not, oh, you really have to look at frozen shops and it's this API call that can return funky things. It's, I think there's something wrong with the varnish caches. And in fact, again, when that engineer was interviewed about this particular incident, his mind went back to the generalization of varnish caches, which, by the way, is one of the things that that engineer looked at in this incident. So we found a bonus heuristic on testing the fix, which I thought was kind of funny. Now, I want to do another sort of simple survey here. When you do raise your hand if when you do a deployment, as a rule, you wait for your tests to pass first. Okay. Now, keep your hands up for a sec. Now, imagine you had an outage and you had time pressure, and people are asking you to just try something, get the site back up. Would you deploy the fix without, put your hands down if you do deploy the fix without running tests, and you just deploy, if it was just a one-line config change, and you thought you knew you could do it. So I see some of the hands going down. I see one person doing this, which is kind of funny. So that's what he found, actually. He did a survey where 1 would never wait for automated tests, and 5 is always wait for automated tests. And he found that during production incidents, a lot of engineers are actually in the 2 to 3 area, right? The heuristic judgment that they will use is how big is the change, and I trust my peers to review it before actually letting all the unit tests run when I'm in this pressure situation. So that was kind of interesting. I also like the kind of YOLO engineer of one over there just kind of deploying without tests ever. It's fine. It's probably fine. It's good. So the point is we use both of these systems. We use system 1, system 2, and we kind of actually oscillate between them. So back to this question. So how do you get better at detecting an incident is occurring? Well, you monitor things better, right? Still not a trick question. Somebody is like, containers. You can do things better if you have containers. So then the question, though, is how do you get better at knowing what to do when an incident is actually occurring, right? This is really kind of what we want to know. And to figure that out, we can look at some research that was done by Hoffman and Klein on the elements of expertise. And what they found in their research is that experts use their knowledge base to recognize typicality in situations. So how typical does this situation look to me? And what heuristics do I use, not to know what's going on, but to understand how far from normal this situation might be. Make fine discriminations. So that's being able to see fine details that people that are less experienced might not be able to see. Use mental simulations. So that means that they can very quickly simulate in their minds what caused this incident. And they're not making hypotheses, they're just simulating what the possibilities are, and then looking at those simulations and trying to extrapolate, okay, what are the possible outcomes? And those are generating paths to search of what I might do. And then finally, knowledge base is also used to apply what they call higher level rules. And it's really interesting, they talk about the reason that novices don't apply their knowledge base to higher level rules is because when they do, it generally doesn't work out for them because they don't have enough of a knowledge base yet, right? So expertise is having enough of a knowledge base to really facilitate what's going on here. So this is a really interesting quotation. With experience, a person gains the ability to visualize how a situation developed and imagine how it's going to turn out. And this is the most important part. The experts can see what isn't there. They don't see what is there, they see what is missing or lacking in the situation. And they can have some knowledge and reason about what's actually going on. So how can you promote sort of obtaining this expertise? Well, there's a couple ways to do it. You've probably heard about the 10,000 hour rule. It was popularized by Malcolm Gladwell in Outliers. And you're probably going to say to me, yeah, but Malcolm Gladwell, right? He always gets the science all wrong, right? So I actually went and looked at the study that book is based on. It's called The Role of Deliberate Practice in the Acquisition of Expert Performance. What's interesting about the researcher involved here is he also said, yeah, but Malcolm Gladwell, because he published a study after that book came out called Why Expert Performance is Special and Can't Be Extrapolated, a Response to Criticisms. So he's probably kind of tired of what Malcolm Gladwell did to his research as well. But the research looks into very specifically tasks that we might assume there's an inherent trait component, so like a genetic component. So they looked at things like sports and music and that kind of thing. But also with people that show that talent for it and also show the commitment to practicing it, what the gains over time that they can experience by what they call deliberate practice. And that's very focused intent practice. We might call it actually flow, right? When we're in flow programming, we're actually practicing getting better at our craft. Now, of course, we're not the only one who does this, and if you know me, I give a lot of talks with airplane analogies, so I had to put an airplane analogy in here. So I'll give you an example of, though, expertise in aviation. This is Captain Sullenberger, The Miracle on the Hudson. One of the interesting things about the situation is that when the engine stopped turning, he immediately turned on the APU. Now that is number 10 or 15 in the checklist that you're supposed to run, but he did it immediately. And when asked later, he was kind of like, I don't know why I did it, I just did it. And they needed that because it turns out that they needed the power to control the flight surfaces, which are useful if you're going to land in the water. He also immediately took control of the airplane. And you might think to yourself, oh, that's because he's the captain, it's an experience thing, and it's just I want to be in control because I'm the captain. And it turns out it's not that at all. His co-pilot was new to the A320 and had only had about, I think it was something like couple hundred hours. Had flown jets a long time before that, but in terms of the type, new to the type. He had been flying in the A320 for thousands of hours at that point. And he felt that he was really an expert in managing the energy, but he also knew that, the other pilot had just come out of training. It would know everything in the checklists, because he'd been studying the checklists to pass the check ride. So that's why he made that particular decision to do that. And then, of course, not attempting to land at LaGuardia, again, because as a private pilot, we're always taught, try to make it back to the airport. And if you listen to the tapes, he got to a point where he was like, that's not an option. And had he tried to turn a bunch of simulations, have shown that he would have crashed into New York, somewhere in the city. Now, this is what expertise looks like in aviation. Of course, we all know what expertise looks like in operations. 10,000 hours worth. So how do you transform expertise into experience? So again, Hoffman and Klein looked at different ways that you can do this. Personal experiences, and this is important. It's not just doing the thing. It's not just being an operations engineer for 10 years. It's being continually challenged, whether it's playing the piano or being an operations engineer. So growth. Directed experience, receiving tutoring, the point of which is not to get the feedback, but actually to learn how to be a tutor to someone else at some point in the future. Manufactured experiences is training simulation, right? And then vicarious experiences, these are things that we tell stories, we create a narrative and stories that we tell others about because they were so good or bad, as the case may be. And as we've seen, right, we call that on-call. Personal experience is on-call. Directed experience is kind of interesting. If you do training, it's training, but I think the one that fits most is code review or pair programming, right? You learn how to be a good code reviewer or a good pair programmer by having somebody who is good at that did that with you when you were earlier in your journey. Manufacturer experience, chaos engineering, game days. I was actually looking up, there's a great talk a couple years ago at Monitorama from the Stripe folks about how they do that. And then vicarious experience. I remember this one incident, and it was DNS, because obviously. So the last bit, the second part about how you can sort of build your ability to sort of monitor, your monitoring ability, if you will, in an operations context, is to do what's called explore discretionary spaces. So this comes from research that was done after actually the 3 Mile Island incident by a Swedish, I believe, although he might be Danish, researcher named Jens Rasmussen. And this is from his paper called Modeling Risk in a Dynamic Society. And it's called the Rasmussen triangle. And so the idea is that you've got these 3 boundaries. One boundary is the boundary of economic failure. So this is the idea that if we cross that boundary, it would be too expensive. We wouldn't do it. Nobody would pay for it because it would be too expensive. We have the boundary of unacceptable workload. So that's the idea that humans are lazy, and I don't mean that in an insulting way. I mean, we all try to get the most bang for the buck out of each molecule of sugar in our brain. So we want to take the least effort to do the most benefit of work or most unit of work. So over that boundary, we won't do it because it takes too much effort. And then this final boundary is acceptable performance, or sometimes called acceptable risk. And you know what happens when you cross that boundary, right? Bad things happen, right? So you have this idea that you have these 3 boundaries. And on the financial boundary or economic boundary, he calls them pressure gradients. And the idea is this is the standard cheaper, better, faster. The business wants things cheaper, better, faster. So they're going to push the system away from the expensive boundary, right? Then you've got people working in systems. They're going to try to do the most amount of work, least effort. So they're going to push less work, right? Now, if you notice, what boundary are we happily going toward? The unhappy boundary, right? So sometimes this triangle is shown with a dotted line. And this is sort of our perception of where that boundary is. And these boundaries move in systems over time. So the actual place where that cliff that we might fall off is constantly moving. But this is where we think it is. And so they call this kind of blob the discretionary space. So it's the space that we allow workers in this system to sort of explore. And we can kind of actually think of this as the thing that would go across the accident boundary, if you will. So the goal here is to allow us to actually explore this discretionary space as much as possible. Get as wide a lay of that boundary that we can, so that we have a better sense of when we're going towards that boundary. And if we do things like game days or chaos days, then we also can get really good at, if we cross this boundary, we can actually know that we've crossed it and then wrestle the system back across that accident boundary before it's really a big problem. And by the way, if you look at big organizations that are good at this, this is the difference between an incident and an accident. An incident is you cross this boundary, but you solved it quick enough, and an accident is you cross this boundary and you couldn't solve it for some reason. Either the system was moving too quickly or the right skills weren't there or what have you. One of the things I wanted to point out from the Google SRE book, which I found really interesting, is, of course, monitoring is at the bottom of this, and we're all here, so we all know that. But I thought it was interesting that incident response and postmortem root cause analysis is right above that, right? And that sort of makes sense if you think about it, because that is where all of the operational part that makes complex operational systems work, that's where we learn how to deal with those systems and how to wrangle those systems. Now, one of the other interesting things that I would point out is this is Etsy's debriefing facilitation guide, and I can't tell you how many people do like root cause analysis, postmortems, retros, good, awesome, perfect. And I can't tell you how many people say, oh, well, the reason we do those is because we want to find the root cause and we want to find the remediation item. We want to do retrospectives like Etsy does them because they always find the root cause. I can't tell you how many times I've heard that. And it's really interesting because that's not actually why they do retros at all. The two questions that they have at the end of the debriefing guide is, did at least one person learn one thing that will affect how they work in the future? And did at least half of the attendees say they would attend another debriefing in the future, right? So they're interested in, did someone learn something? And was the experience good enough for at least half of the attendees that we would keep doing it and that you would want to keep doing it? But it's not about filing JIRA tickets so you can actually find the remediation item, because those model linear systems, and we don't live in linear systems. So, question that we asked, how do you get better at knowing what to do when an incident is occurring? Well, turns out the answer is create space and experiences to facilitate the cultivation of ourselves and our teams to improve our heuristics so as to detect weak signals and ambiguity in the complex socio-technical systems we operate and in which we exist. Or another way to say that, practice makes better, it doesn't make perfect. Expertise takes time and space, so you need to make time and space if you want expertise. You need to make time and space for it. And finally, it may be hard to see this, but for people that know this photo, this is the picture that Voyager took as it exited our solar system. And I really liked it because I think we can all agree that the universe is pretty chaotic. And it's just us out here, right? Everyone that we've ever known and everything that has ever happened that we know of has happened on that little blue dot, right? So similarly in incidents, when we look at our teams and ourselves, it's just us out there, and it's a chaotic world. So as you're going on this journey to expertise, be good to each other. This is really what Blameless is about, because we're all in this together as we're on our journey to becoming experts. Thanks.